Well, good morning, everyone. For those that's been in here, welcome back. What I'm going to talk about in this session is our electric product recovery line, our Scavenger product recovery. We have a full line of pneumatic product recovery systems where you would use an electric system rather than a pneumatic system. There's a couple of different reasons. One, you have a lot more product to pump rather than pumping, or rather than wells that maybe have inches of product, you have wells that have feet of product with a high recharge rate, and you're looking to recover thousands or tens of thousands of gallons of product. And also, if you need to, in a situation where you have a large enough diameter well, or maximum 4-inch diameter well, you can actually pump water to create your cone of depression to bring more product into the well with an electric system. So we're going to get started here just by taking a look at a map that we have. Basically just shows a leaking underground tank, how it impacts the soil and get the floating hydrocarbon layer on the water, and then the groundwater dissolved. The dissolved layer in the groundwater. In the restoration program, in the last session, Jeff talked about, air stripping systems, and water pumping systems. But also in this, we have a full line of hydrocarbon product recovery systems. And that's what we have here, pumping into a storage tank. So we start with our large diameter filter scavenger. This system was developed in 1975, and we actually had a patent on it. And what it uses is a hydrophobic oleophilic filter or a screen. What that means is it's a stainless steel screen, 100 mesh, 100 holes per inch, coated with a Teflon material, and it allows oil to wet it and pass through, but not water. So if you have like a non-stick pan at your house, whether it's the old style Teflon or the new ceramic, if you pour water on it, water beads up because it can't wet the surface. But if you pour oil on it, the oil spreads out because it can wet the surface. Same kind of, same technology here. It's designed for a 24-inch diameter well or an interceptor trench. And it's been engineered and weighted so that it floats at the oil-water interface so we can skim product down to a sheen. It has a surface-mounted pump with explosion-proof controls because when the system was developed, we were recovering mainly gasoline. And it's a shallow well application, so the controls and the pump and motor had to be at the wellhead. So it was always in a class 1, div 1 area. So the motor is explosion-proof. The controls on the control panel, or the boxes and everything, are all explosion-proof. This is the unit here. Get the laser pointer. This is the flying saucer-looking unit. Here is the lid. Underneath there is a bowl that we call the buoy. There's 4 floats on the outer of this lid that help it float at that oil-water interface. And in between the lid and the bowl is the hydrophobic filter. Looks like a 1970s car air filter is what it looks like. It's round, and it fits in between, and that way it floats at the oil-water interface and recovers all the product. Inside that bowl are float switches that turn the pump on and off automatically. Just another picture here showing an updated carrying case that we supply with it. The control panel here, you can see the box. It's a big aluminum box that's explosion-proof. The motor and the pump as well. Here's a picture of the buoy and the lid. You can see the product layer here in orange or red, whatever the color the screen is showing here. We got the filter in between the lid and the bowl, and inside are 2 float switches. The center float is the oil float that will float in any fluid that gets into the bowl. Once the bowl is full, the float rises up, trips the switch, turns the pump on, and empties the bowl. Once that float falls, the pump shuts off, so it's an automatic system. The second float, the smaller one that's to the right, is a water float. It will only float in water. So even though it's a smaller float, it's more dense. And so when there's product in there, it won't float in the product. And the reason we have that float in there is if water gets past the screen for whatever reason, there's damage to it, or it gets flooded, or is not floating properly, we don't want to fill the bowl with water and then have that water fill your recovery tank.
Does that just like trip an alarm, or just doesn't?
It will trip an alarm. It will trip a light on the control panel to tell you that it's an alarm, and it will shut the pump off, so it will not run. This is just a picture showing a typical application. We got the controller inside the case at the surface, tank full switch that would go into your recovery tank. So when the tank is full, disables the pump so it won't overfill. And again, as I said, it was a shallow well application. So we've got the hoses and the cable attached going down the well to the buoy lid and the filter. There's a check valve so that we don't backfill any fluid back into the well. So based on that system, we had sites where the depth to water was more than 20 feet. Because it's a shallow well, I should have mentioned before, because it's a shallow well system, we're limited to about 20-foot depth to water. You draw a suction on gasoline more than 20 feet, you're going to vaporize it. So you're not going to get any fluid, you're just going to get vapor. So in applications where you're more than 20 feet depth to water, we made a modification to the filter scavenger, calling it the large diameter dangle scavenger, and you'll see what I mean by dangle here in a second. It's designed for the same diameter, same type of well, same type of controls, same specifications as the filter scavenger I just showed you, but what we did is to accommodate the deeper well application is we took the pump and motor off of the baseboard, off the control panel, and put it on and suspended on a winch down the well. So that way you keep the intake of the pump within that 20-foot range of the bowl and the lid. And this shows you the application or the installation diagram. You got your control panel here. It's still explosion proof. You got a winch that suspends the pump and motor, and it's in the well, so it's in that classified zone, so that motor is explosion proof. And again, it just attaches. It's within 20 feet of the water table.
And what's the max depth of these? Like what
the pump itself can produce up to 60 psi, so it can overcome up to 60 psi of back pressure on the discharge side. And we limit it to 60 psi that way because the input hose here is a urethane hose. If it gets higher than that, you're going to burst the hose. You don't want that to happen. And so for smaller diameter applications, we developed we call a small diameter filter scavenger, designed for as little as a 4-inch diameter well. Uses the same oleophilic hydrophobic membrane, but in a smaller package. Separates oil from water. This particular system has a floating intake with 1 foot of travel that can adjust to water table fluctuations. It's designed for the same light fuels that the large diameter filter scavenger is, up to number 4 max. We can skim product to a sheen. And we can also set this up as a dual pump arrangement, putting a Grumpus Ready Flow 4 pump on the bottom of the product pump jacket so that you can create your cone of depression and bring more product into the well. And then there are 2 fluid streams going out of the well, separated from each other. You've got the water going to your treatment and product going into your recovery tank. Can operate to depths up to 150 feet, and the controls, standard controls are NEMA 4, non-explosion proof, but we can supply explosion proof controls if you're in a classified area that you need them. This is the small diameter filter scavenger here. The pump on the left is what we call our product only model. This is the float with the hydrophobic oleophilic membrane on it. It floats at the oil-water interface. Product travels through there, through the tubing here, and down into a reservoir that has a float switch. When the reservoir is full, the float switch rises. turns the pump that is housed underneath the reservoir. So it's a submersible pump that will produce up to 100 psi and pushes it to the surface. Once the reservoir is empty, the float falls, shuts the pump off. Again, it's an automatic system. On the right is the same system, but set up in a what we call a water table depression pump ready model. We put a Grumpus Ready Flow 4 on the bottom, and we can pump up to 20 gallons per minute. It's a 1-inch discharge at the top of the pump itself, so water will travel through a separated tubing and out, and that would go to your water treatment, where the product would go to your recovery tank. And so the function of that water pump is to create a cone of depression. You reduce the water, you lower the water table down to where you're going to get recharged. Product comes into the well faster because it's less dense. You create a larger product layer, and it's easier to recover. And you keep control of the plume as well, keeping it from migrating out. And this just shows an illustration showing how you got that cone of depression. Your water table is normally here. We pump it down so it's a little bit lower, and then it shows the product coming in, going into the filter, into the membrane, and then showing the Grumpus Ready Flow 4 pump there. The water discharge and product discharge. And again, this just shows a typical installation diagram. The pump pumped in the well, product going to a recovery tank, and your controls, whether they're NEMA 4 or explosion proof. If they're NEMA 4, you put them in a non-classified area, and you can run electrical, whatever distance you need. Because explosion proof controls are very expensive, so NEMA 4 is the most common. But if you're like at a refinery that you don't have a non-classified area, we can supply the controls as explosion proof. We also have a system called a small diameter probe scavenger. The difference between a filter scavenger uses that hydrophobic oleophilic filter membrane. A probe scavenger uses a fixed intake, a level probe with floats on it that turn the pump on and off. Again, it's designed for a 4-inch diameter well. It's a fixed intake, so the intake does not rise up and down with the water table fluctuation. But we have a level probe that has, and I'll show you a picture of it here shortly, has 2 floats on it, one to turn the product pump on, and where, as with the small diameter filter scavenger, you can set this up as a dual pump system. There's a water float on that probe that will turn the water pump on and off. This system would be used at, say, a transfer station or a refinery where you're not worried about skimming product down to a sheen. You've got thousands, maybe millions of gallons of product to recover. And so you're not worried about, you're just worried about getting the bulk of the product out of the well. So this is going to, because it's a fixed intake and we're using that level probe, we're limited to about reducing the product layer to about 2 inches. As with the small diameter filter scavenger, it uses the same pump as the small diameter filter scavenger, so we can operate down to around 150 feet. We can modify this system to recover DNAPL, like chlorinated solvents. And it's supplied with the same NEMA 4 type controls that the previous system I showed you. The probe scavenger here looks very similar to the small diameter filter scavenger, except we don't have that oleophilic membrane now. We have a level probe with an intake. This is the product only model. There's no reservoir, but the pump and motor are housed in this housing here. It's all stainless steel, and so your product discharge would be based on where you set this at the oil water interface. And once the float rises, turns the pump on, pushes the product to the surface. Once it's pumped all the product off the top of the water table down to 2 inches, the float falls, shuts the pump off, turns it back on as it recharges. The one on the right is the, the dual pump arrangement. Grumpus pump would thread onto the bottom here, and this same probe has 2 floats, one for the product and one for the water. And again, two different liquid streams coming out of the well. water would go to your recovery, or water would go to your treatment system, product to your recovery tank. Illustration showing it in the well, the water pump creating the cone of depression again, building up the product layer for the level probe to turn the product pump on and push it to the surface. And just showing the illustration of an installation diagram as we showed with the other systems. That same shallow well, or that same probe scavenger, we had applications where someone trying to recover from a monitoring well. And so because the limitation of the probe scavenger is a 4-inch diameter well, it's about 3.5 inches in diameter, so that's the minimum size well that would fit in. So for recovering from a monitoring well, we have a shallow well system, basically using a fixed intake with a level probe, but it's as the title of the system tells you, it's for shallow wells. So you're about 20-foot depth is the limitation for this system here. It will recover gasoline up to number 4. Because it's a probe scavenger, it will reduce the product layer to about 2 inches. The system comes with a control panel and pump that are explosion proof because you're 20 feet, the controls are being at the wellhead. This unit here looks a lot like the large diameter filter scavenger, the first unit I showed you. So instead of that lid and bowl setup, there is we stick this down the 2-inch diameter well. This is an intake with a level probe that turns the pump and motor on automatically based on the probe float position. Installation diagram. Here's the control panel. Actually, it's the same control panel as the large diameter filter scavenger. We use the same carrying case, storage case with a tank full probe. Here's a larger picture of the intake itself with a check valve, and then the probe is lined up with the intake. And you put it at the oil-water interface, and as long as you don't have any water table fluctuations, you'll have to adjust it if you do. But again, this will work in a 2-inch diameter well. High volume probe scavenger. This is for sites, again, refineries. 8-inch diameter well or larger. Operates on 230-volt single-phase power. Designed for gasoline, same kind of application up to number 4 fuel viscosity. It's a fixed intake using a level probe to turn the pump on and off. And again, as with all the other probe scavenger versions I showed you, it reduced the product layer down to about 2 inches. The pump will pump up to 10 gallons per minute, so that tells you how much product this type of system is designed for. Max operating depth is about 80 feet. It's a standalone recovery system, or we can put it in a well, a large enough diameter well with a separate running flow 4 or a ready flow 4 Krampus pump, or larger, depending on what you need for water flow rate to maintain that cone of depression. Supplied with a tank full probe for the recovery tank, as with all the product recovery systems, and we provide it with NEMA 4 controls. Here on this high volume probe scavenger, this is a pump that's installed at all of the gas stations. So when you go to self-serve station and you fill your car up, this is the type of pump that's in the tank that's filling your car up. So this is the intake for it, and then the level probe matched or attached next to it at the right dimension, so that the level probe is matched with the intake. Typical installation, as with the other probe scavengers, you've got it down the well, and this is a product only setup. It doesn't show the water pump, but it just shows the product coming into the well next to the level probe. This particular system here, there's a site in Brooklyn, New York. I'm not sure you've heard of it. It's an ExxonMobil site, Greenpoint. They've recovered roughly 14 million gallons of product since the late 80s. And they have probably near around 10 to 15 of these systems throughout that site. They've also got 75 gallon per minute gruntless pumps in those wells. So they have 8-inch diameter wells that have both of these pumps set into. And they're pumping about 1 million gallons a day and treating that water before they recharge it. And for two reasons. They're trying to control the plume because it's in a residential area as well. It's the old John D. Rockefeller's, the old refinery, Standard Oil site. But there's a residential area there as well, so they're trying to keep the plume from migrating into people's basements. So they have to pump 1 million gallons of water to keep control of it, but they're also creating that cone of depression, increasing the product layer, so it makes it easier to recover. So this is a system that's at that site. So based on it, anybody have any questions?
How long do you think it's going to take to remediate all that at that site?
Oh, at that site, they predict they have another 14 million gallons in the ground to recover. So it's next 20, 30, 40 years. It's a long term. Everybody jokes that's the U.S. oil reserve right there. And it's interesting, when they first started pumping product out of the well, it was whale oil. They had a whaling operation at that site. They would drag the whales up Newtown Creek and actually slaughter them right on site. That's what they used, for the old lamps back at the turn of the century. So I guess the stuff smelled horrible when it was coming out of the ground. They're not recovering much whale oil anymore. They've got pretty much all that gone, but it's. And I guess they found that site simply by accident. There was a news helicopter, a New York news helicopter that was flying over doing a report, and they saw this sludge coming out on one of the discharge pipes into the creek, and reported it, and that's how they found that site and all the problems at that site.
What do they do with the treated water?
They have oil water separators, and they have a catalytic oxidizers at their thermal oxidizers at that site, so they're treating the water on site before they re-inject it back into the ground. It's a pretty big site, pretty famous site.
You mentioned configuration for the smaller diameter wells that would be set up for denouncing.
Yes.
Can you show how that would be configured?
Yeah, what I don't have a picture of it here, but what we would do is take this system here and basically invert it, put it upside down. Obviously the probe would be upside down, but we'd invert the pump so that the intake is at the bottom rather than at the top, and then put a probe next to it with a connectivity sensor so that it will recover the DNAPL, but once water gets down close to the probe, it would sense the water and shut the pump on.
Not the floating sensor, but a separate connectivity.
Separate connectivity sensor.
Yeah, gotcha. Do you have any case studies where you've done that? You can talk about.
I'd have to look. We have done it, but they're older sites, from like back in maybe the 80s and 90s that we've done. We haven't really done any lately, but we designed a system based on a customer application. Basically modified a system based on their application needs. But I can find something, get your information, I can find something and send to you.
Right.
Anything else?
Who's paying to clean that up?
I'm interested in this site. I'm not sure. It's yeah, probably taxpayers. It's an ExxonMobil site, so I'm sure that they're making money from the product they're recovering as well. They're refining it or selling it back to
We
somebody.
all are.
Yeah.
Yeah.
Every day at the pump.
Right. Yeah.
Paying for it twice.
Right.
Yeah.
All right, great, thank you.
Thank you.
Thank you.